Putting it on switch on again. Let's start off. This was the last thing that we did. Comes on everyone. Hope everyone has resolved the properties of Matrix paper. See what went wrong. Paper was really not that difficult. Maybe you guys didn't do enough practice. Like a poster in the group next week, I'll be putting one more paper, additional practice. So you can write that. Again, I'm telling you, don't give up now. Last 5-6 months, this next topic which are coming up, try to focus. I know, it won't be able to complete everything. If there is 100 to do, if you can do only 60 to 70, chalega, at least do that much. Most people are, crying, sir, 100 to do, there's 100 to do, there's 100 to do, ठीक है, 100 to do, but you can do only 60 na. At least wo to karo na. Sitting and crying 100, and you do end of the day 20. What is the whole point of it? So don't try to be a perfectionist. You have to do 100, but you can do 60. Chalega, do that 60 properly at least. But sitting and crying and doing only 20 doesn't make sense. And make sure to send reports, everyone. You guys are not sending reports. I have to assume you guys are not doing work. Do send. Every day morning, half an hour, abhi mera kaam wahi ho gaya. I'm replying people. Do that, do this, don't do that. Do send. Let's see. Other scams on. Aviksha, Anamai, camps on. Divanshu, where are the rest? Many people bunked today. Let's see a question. Let's start off with an good one, and then we'll go ahead. Today, we'll be doing circuits. We'll skip some of the circuits, which we did in capacitors. We'll be little different ones. So let's say we have a hollow cylinder. This radius is A. This radius is B. The length of the cylinder is L. Resistivity is rho. So if you connect the battery between this and this, what is the resistance? What if you connect the battery between the inside and outside? What is the resistance? Find resistance between 1 and 2, that is left and right. Battery is connected between the left end and the right end. You have done this in heat transfer. Find the resistance between 3 and 4. That is, battery is connected between the inner surface and the outer surface. And the length of this thing is much greater than B minus. So the thickness is quite small. Basically, to neglect the fringe effects, the edges will get messed up. Get these two. If you connect a battery between the left and the right side, what is the resistance? If you connect the battery between inside and outside, find the resistance. Anyone confused with the question, please ask. And if you're wondering, we have done this in heat transfer. Exact same question. Questions or repeat. Exact same question. Try. You got a minute for the first one, 2 minutes for the second one. Anyone is confused, please ask. A plus B आया Kavish, नहीं रे. You goofed up first part. First part is the easiest one, right? See the first one. How is the current flowing in the first part? The formula resistance is rho L by area. L is the length along the flow. A is the area perpendicular to the flow. So this is rho L by pi into the area would be B square minus A square. Take step answer, isn't it? Because when the current is flowing, it is passing through this cross section. The current is flowing in this cross section here. Isn't it? That area you should take. What about the second one? What if you go from inside to outside? Try, I'll give you a minute more. Now try to understand. See, this is how your thought process should go. When the current is going from inside to outside, the formula is rho into length into area. Okay, perfect. So what will be the length? This B minus A. Great. What will you take area? Area
We'll
perpendicular to the flow. Will you take inside area? Will you take outside area? It is changing, right?
We'll have to take rings.
So matlab you have to integrate. See, did you guys see the idea? Rho L by area is changing. Matlab ho gaya na, you can't use the formula directly. We have to take thin cylinders at a distance x and integrate for each cylinder. That is how you should think. That is how you know when you have to integrate. Look at for the first part. First part ke liye area same for every cross section, isn't it? So there is no problem. But for the second part, area is changing. So you have to integrate. Try. I'll give you a minute.
Sir, ln B by.
So we take at a distance x, we take a thin strip. Whose width will be dx. So the small resistance will be rho into length into area. Surface area of a cylinder is 2 pi x into L. So we are actually getting this area, everyone. I will take this surface area radial to the flow. And all these elements are what, series or parallel? All these elements are in series or parallel? Anyone? Series? Why?
Series.
Why?
Same current.
Same current flows, no? All these thin cylinders are in series.
Potential difference across individual ones is different.
Yeah. Again, if they're in series, you directly can add them. So we get R is equal to integral rho dx by 2 pi L into x. Limits will go from A to B. That will be rho by 2 pi L ln B by A. That dx by x is ln integral. Check, that's your resistance, everyone. 2 pi XL surface area of a cylinder, right? What is the curved surface of a cylinder? Circumference into length, no? Sure. Please check, it's a good one. Any doubts on this? Anyone not clear? Reina, clear with this? Dipanshu, got this? Chirayu? Perfect. Laddi, got this, no? Can I go ahead?
Sir, 1 minute.
Nikita? Nishita, clear? Great.
Yes, sir.
Next thing. We have a solid sphere with a cavity. Means you can't actually see the cavity. Inner radius is A, outer radius is 2A. Rho is equal to rho naught x square. This is the resistivity. X lies between 2A to A. So as you're going out, the resistance is becoming more and more. The resistivity as function of X. You have connected the battery between the inside and the outside. This is the voltage V. Battery V is connected between inside and outside. Find resistance, find current, find the current density as function of X coordinate, find the electric field as function of X coordinate, find V drift as function of X coordinate. X coordinate, X is the distance from the center. Assume N is constant, N is the number of electrons per unit volume. X is the distance from center. This will be integer questions, huh? J is proportional to X power minus N, find N. Let's get this. This is a solid sphere with a cavity. Inner radius is A and outer radius is 2A. Ideally speaking, you can't see this cavity. So you have connected the battery between the inner surface and the outer surface. So current is going from inside to outside. Radially, it is flowing out. Find the resistance, current, the current density, J is current density, current per unit area, electric field, and V drift velocity as function of X. Get them out.
Sir, rho upon 8 pi A R equal.
So upon 8 by integrate किया.
हाँ सर.
चलो देखते हैं. One more minute. Let's find the resistance first. See, Again, it is all about how do you choose your element properly. So at a distance x, take a thin strip of width dx. So for this, the small resistance dr will be rho, length will be dx. Understand how you're getting the length. You're taking the length dx because the current is flowing this way. The current is flowing radially outward. So you should take the length along the current flow. By area is 4 pi x square. But your rho itself is rho naught x square. That x square cancels off actually. Rho naught dx by 4 pi. So all these are in series. So R equivalent will be integral dr. That would be rho naught by 4 pi integral dx. Limits will go from a to 2a. That would be rho naught a by 4 pi. Straightforward, easy. What is current? Voltage by resistance. What is current density? Current by area. Current is V by R and area is 4 pi x square. And understand here, current is constant. I is equal to V by R is constant. Current does not change because whatever charge that flows through a cross section, it has to remain same. So current J is proportional to 1 by x square. We also know J is equal to sigma E. E is equal to J into J by sigma. That is nothing but J into rho. So electric field will be J, that is I by 4 pi x square into rho will be rho naught x square. X square cancels off. This is a constant. This is interesting. The electric field has become constant inside. So E is proportional to x power 0. It does not depend on the x coordinate. What else you want? Drift velocity. I is equal to NEA V drift. Current is constant, N is constant, E is constant. The V drift is proportional to 1 by area. That will be 1 by 4 pi x square, 1 by x square. Please check. Like I said, once you got the resistance, everything else is easy. You'll get V by R. Current is the current density is I by area. J is sigma E. Is NEAVD. Sub formulas डाल देना. Do check out the values. I can keep changing the rho के values now. Rho naught x, rho naught is constant. I get different values of R. Have a look at the steps. Clear? You didn't take x square, इसीलिए तुझे वो आया. Any doubts on this? Tanya, clear? Anamay, Trisha, clear? Divyanshu, Amu, clear? Chirayu, Kavish, got this? Perfect. Next one. Next one is a good one, right? So this point is x is equal to 0. This point is x is equal to a. And this point is x is equal to a plus d. Matlab this thickness is d. A is much greater than d to neglect the fringe effects. The current will start getting messed up on the edges. This angle is theta. This resistivity is rho. You're connecting the battery between A and B. if you look at this in the top view, so this is a part of a
hollow cylinder.
hollow cylinder. You can see pizza ka crust. It looks like that, na? Thoda pizza ka slice ka pizza ka crust jaisa. Theta. So you're connecting the battery between this guy and this guy. Find RAB. Find the resistance between A and B. I hope everyone can visualize how is this element. Hollow cylinder ka part of it. And this length is L. Height of the piece is L. Width is D. Angle theta. Resistivity rho. If you connect the battery between these two edges A and B, find the resistance. Try. It's a good one. I'll give you 2-3 minutes. How do you approach this? The most important thing, how do you choose an element? Start with that. Think about how to choose an element. Can I choose an element like this?
It's like a
Can I
zero
take elements
sixty
like this? Can I take elements like this? Yes, no. Suppose if I take elements like this, are they in series or parallel? What is same for them? Isn't current same for all of them? They're in series now, but you can't take them. Any idea why? When you take rho L by area, what will you take length? Can you see the length is changing, isn't it? Every strip will have different length. Isn't it? As it is going out, observe this thing. This length, na, it is like this. The angle is same, na? This length and this length won't be same. Are you getting it? You get a non-uniform rectangles. Those are not rectangles. वो कुछ और shape था वो. Trapezium types. You won't be able to solve them. Even though they are in series, you won't be able to find rho L by area. You can't find length. Length itself is changing. So how do you choose an element? This would be a better one. This is how you choose an element. Isn't it? This is how it looks. What are these elements in series or parallel? Parallel, right? All have same potential difference, na? AB, 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 AB. Now can you try? Try. I'll give 2 minutes from here. That's it. That's the main thing. If you know how to find the element, your job's easy. That's how you choose an element. So you take a thin element of dx thickness and you solve from there.
sir, R equivalent is a linear quantity.
मतलब क्या होता है? R equivalent is a linear quantity. R equivalent is resistance. What do you mean by linear quantity?
मतलब ऐसा unitary type लगा सकते हैं क्या?
नहीं कर सकते. Who told you? It's not a linear function.
Okay.
See. So for this element, if you take the small resistance, now you have to be careful with integration here. Rho, what is the length? What is the length of the strip? Let this distance be x from here. X theta, na? Nah, dx is not the length of the strip. What is the length again? L is the length along the current flow. How is the current flowing? The current is flowing like this, right? Everyone. The current flows along this thing. You should take this length, arc length. So length will be x into theta. By what is the area? Area perpendicular to the flow means you're taking this area. That will be L into dx. And we know 1 by R equivalent is summation of 1 by Ri. That is integral 1 by dr. You have to integrate 1 by dr. You should not integrate dr directly. It is 1 by dr1, 1 by dr2. So you have to integrate integral 1 by dr को integrate करना है. So that would be integral 1 by dr will be L dx by rho theta into x. Limits will go from a to a plus d. This will give you 1 by R equivalent. This would be L by rho theta ln x, which will be a plus d by a. Now you have to invert it. So R equivalent will be rho theta by L into ln a plus d by a. Please check your answers. So be careful. This is a series. Parallel, sorry, this is a parallel. So whenever you're integrating a parallel, you should not integrate integral dr. You should integrate 1 by dr. Because parallel ka definition is 1 by R equivalent is 1 by R1, 1 by R2. So summation of 1 by R. Please check. It's a good one. Clear? It's a good one. Any doubts on this, please ask. Clear. Next one. Rishi, clear with this? Hasni, clear? Anamai, Nishita, Vrinda, got this? Abhiksha, clear? Reina? Next one. Now remember, like whenever you solve circuits, there are 5 ways: series parallel, Wheatstone bridge, nodal analysis, symmetries, and Kirchhoff's law. This is the main thing. So whatever you did in capacitors, all that logics are still valid. So let's see some questions based on that. So some other questions we won't repeat. It's only series parallel. Some things, new things we will do. This is A and this is B. All resistors are R. Find RAB. Yeah, nodal analysis. Name the points. If for 2 points are connected by wire, they'll have same potential and finish off from there. Everyone should definitely solve the capacitors sheet which and it has some different circuits and models. You do that, that will help for current also. Whatever techniques you learn there, everything will remain same. Kirchhoff's law will be a little different here, but their Q is CV, यहाँ पे V is IR. That's the only difference in formula. But remaining that symmetry stuff, all that thing is same. Try, you got a minute. It's an easy one. First thing, name the points. If this is A, because this is a wire, this is also A. Agreed? If this is B, this is some point C and this is some point D. C and D are not connected to anyone. Every time you go from across the resistor, the potential changes. Can you find any other point? That's it. There are only 4 points. So starting point is A, ending point is B, the middle is C, and then you have a D. So I'll just name the resistors for you. So this is 1, 2, 3, 4, 5, 6, and 7. 1 is between A and C. 2 is also between A and C. 3 is between C and D. 4 is between A and D. 5 is between A and D. 6 is between D and B. 7 is between A and B. Can you solve this? Series parallel, no? These two are in parallel. Series, parallel, and series. You're done. Check. This is a solvable circuit. Series parallel mein ho jayega. Now I will leave the solving to you. 11R by 19 it seems. Okay, let me check that. R by 2. Just be careful. I'm just worried about one thing. You will mix up capacitors and current ka formulas. You have to be really careful. I do that sometimes. So you have to be careful. R by 2 plus R, 3R by 2. This is R by 2. 3R by 2, R by 2, that is 2R. 3R by 8, 3R by 8 plus R. 11 by 8 plus 11 by 8 by 11 by 19. Perfect, Daniel. You got it right. 11 by 19. That's the answer. Check. All clear with this? So once you got series parallel, jobs done. Clear na, ma'am? Labdi, got this? Next one, going ahead. हाँ Trisha, clear na? Star. Find the resistance between A and B. Each segment is R. Every segment has a resistance R. Symmetries, bisector symmetry, axial symmetry. Try 2 minutes. If
So what
every
was the
segment,
answer? For
why?
A?
Which one? This thing. 11 by
Okay.
90. Try. Again, I'm telling everyone, next Wednesday, try to finish off capacitors. Because you have to start current after Wednesday. You need to keep up with me. Every week, you need to solve parallel with me. Don't wait for a week or 2 weeks. You'll forget everything. And the way the class syllabus is going on in your respective classes, they are rushing like mad. Pace people, I don't know what happened. Suddenly they remember they have to finish it off. Their schedule initially was October end. Now they're saying September end. And right now, Ellen Metho, they went ahead. Vidyalankar, they went ahead, right?
So one track is over, the physics portion.
तो उनको हो ही गया. There must be at least 3 chapters ahead of us. 2 to 3 more.
Yes, some more.
More.
5 chapters.
There. Start solving parallelly. Finish it off.
And then the other track, no, but
So if time permits, right? If time permits, what you can do, you can start doing previous year questions. You can find Arihant ka book from Amazon, or you can go to this app called Marks app. You find all these previous year questions, year wise, chapter wise, subtopic वैसा सब मिलेगा. So you can get previous year questions from there. You can start solving that. That will be quite useful. You have all subjects there. 16th one, how to do this? Try. I'll give you a minute more.
It will be done by symmetries, right?
This is symmetry only, na? You have both symmetries. Axial bhi hai, perpendicular bhi hai. 22 R by 35. Kavish, we have one answer so far. Others, try. See.
So can you wait for 2 minutes?
Try. 19R/6. So if you see, there is a perpendicular bisector symmetry. There is an axial also. This is a perpendicular bisector. In this symmetry, what can you do? You guys remember? If you have a
Nodes
perpendicular
open.
symmetry, nodes can be opened up. You can remove this node here. And you can remove this node here. And you can just join them. And now look at this thing clearly. It is actually series parallel ho gaya. This is R, this is R. They both are in series. Agreed? This is R, this is also R, both are in series. And this is R, all three are in parallel, isn't it? So if you look at this whole section here, that would be 2R, 2R, R, and this would be R/2. This whole section will be R/2. Similarly, if you look at this and this, these both are in series. This is in parallel. So 2R and R are in parallel. This full triangle is 2R/3. Similarly, this full triangle is also 2R/3. So you can just redraw the circuit. It looks like this. So this is point A. 2R/3, R/2, 2R/3. The center resistor will be, there are two resistors in the middle, this one and this one, R and R. The bottom is same as the upper one. 2R/3, R/2, and 2R/3. Please check. This is how the final circuit looks like if you open the nodes. This entire section in the middle, this guy becomes one resistor. This green one and the green one will become one resistor. So total there are three resistors on the top, two resistors in the middle, this and this, and again three in the bottom. Do check this out. If you got this, it's just a matter of solving now. This is how much you're getting. You have two different answers, 19/6 or 22/35. I think it is 22/35. I remember doing it somewhere. Vrunda got the same circuit.
I forgot to take the resistors that went between. But
Ravish got the same
yeah,
circuit.
और I actually did कि जो side वाले triangles है I first resolved those, then that बीच वाला hexagon बचेगा, then I folded it, but I got 22 out of it.
देखते हैं. हाँ वृंदा.
So I'm getting 38/31.
38. चलो solve कर लेते हैं. 2R/3, 2R/3, 4/3, 4/3. 4, 2, 8, 8, 8 plus 3, 11/6, 11/6, 11/12. 11/12 plus into 2R into 2 by 11/12 plus 2. 22/12, that is 12 to 24 plus 11, 25.
20.
Right only. Ravish ka answer right. 22R/35. Check this everyone. All clear with this? Next one. Any doubts on this, please ask me. Once you can remove that node, that simply becomes series parallel, and you know how to do that. Labdi, clear? Find RAD. B, I'll give you as a homework. You can find RBC. Let's do AD right now. What if you put the battery between A and D? You can put the battery between A and D, B and C, B and E, AB actually is all same. These are the only two types you have actually. AD, BE is same. Hmm. Let's get this. A and D. Yes, page here. Next thing. Try. Between A and D. If you're done with that, you can go for B and C. Both are good. Actually, we can do both. We'll do both. See, I'll show you A and D. You can try B and C. So between A and D, the battery is between this guy and this guy. So if you draw a line, can you see the mirror image left and right are same, right? That means if the left and right are same, this point and this point are identical, isn't it? Left and right are same mirror images. If you see E and F have same potential. Similarly, B and C also have same potential. Means anything between them can be removed. Meaning you can remove this guy in the middle. Okay, na question. This becomes simply these three are in series. This are in series. See? The circuit would simply look like this: A and D. Between A and D, there is one resistor. On this side, you have a resistor. resistor and resistor. There are three resistors here. There. So this is one, this is one, this is two, this is two, and this is one, and this is one. So 1, 2, 1, and this is 2. The battery is between these two. Ho gaya na? Series, and all three are in parallel. Please check how we did this. Since the left and right are identical, you can just remove them. Anything between E and F can be removed, anything between B and C can be removed. Using the, can you do for B and C? Try, I'll get another 2 minutes now. You do for B and C. If the battery is between B and C, then how does the circuit look? Resistance between B and C is 3/2. Okay. Try B and C. 1 more minute. Let's see. 3R/2. 3R/2. Vrunda is on fire. So now we are putting between B and C. So this B and this is C. Can you see there is a bisector symmetry? Do you remember along the bisector, what is this? This line is equipotential, right? All the points on this line have same potential. That means anything on this line can be removed. So therefore, A and D have same potential. The midpoints all have same potential. Meaning you can remove this resistor in the middle. The moment you remove that, your life becomes easy again. Can you see? These two are in series. This and this is in parallel. And then you're done actually. This thing you'll get it how to solve. So this is B and this is C. You have 1 in the middle. And then you have a 2. And then you have the triangle 1, 1, 2 and 2 and 1, 2 by 3. And then you have again another 2 here. And outside again you have 1 and another 1 like this. So all are in parallel. This would be how much? 1, 1, 2. This is 2, 2, 4, 4 plus 2 by 3. 4, 3, 12, 14 by 3. Numbers are not that great, right? So we have 2, 14 by 3 and 1 in parallel. I will leave it to you. I don't think you'll get 3R by 2 though. You got 3R by 2. Kavish?
Sir, remove the resistors between E and F and B and C, the bottom ones as well.
Yeah, and you can't remove it in E and F. Na? This line will have same potential,
No.
right? Because see, when the ऐसा सोचो ना, you're traveling, let's say B to C, okay? Let's say this is 100 and this is 0. When you go from B to E and E to F and F to C, how can E and F be same? You're getting the difference? Meaning what will be same, you know, let's say 100 to E is 75. Let's say this is 66. This is 33. So 100 minus 66, 33 minus the difference will be same. But in the previous case, why did I remove that? Because previous case was a little different. In the previous case, you're coming from up to down, right? When you're coming from here to here, now think about it. When I'm coming like this, if you say this is X, this is also X, no? That's why you can remove them. Kitna hai, Rishi? 26 by 45. Chalo, we'll assume that is right.
सर बट वो बीच में का जो ट्राइंगल था ना उसका 8/3 आता है ना
This is
No.
1 and
Oh,
no,
I messed up.
you messed up. ये actually 1, 1, 2, 2, 1 का parallel है ना? Add नहीं करना।
हाँ वो parallel था. I
क्या
took
मैं-
all three of them in parallel.
Clear with this? I hope you're getting the circuits. You can do the same thing in capacitors also. Let's see one more like this. I hope everyone is getting the hang of the symmetries and stuff. Let's get this. That cube symmetry, infinite grids, all will be exactly same. So we are not repeating them again. So you want resistance between O and P. O is here. P is here. You want to go from O to P. You can see a symmetry there. Can't you see the symmetry here?
Yes,
A, B,
Papa.
C, D are identical. Isn't it? When you go from O to P, you can go from OAP, OBP, and OCP, ODP, doesn't matter. All are identical. देखो ना, ABCD are identical. Therefore, all resistors between ABCD can be removed. Because they have same potential. Then you know how is this circuit becomes like, this is O. There are 4 wires like this, A, B, C, and D. And this is P. This looks like this, na? I can simplify it further. So this is O, A, B, C, D, and this is P. So O to A, O to B, O to C, O to D, A to P, B to P, C to P, D to P, 4 resistors. And he said the resistance of each wire is R. So let this resistance be R1 and this resistance be R2. So this length is R. What is this length here? 1/4 of a length, 1/4 of a circumference. This will be pi A by 2. And this is A. So R1 will be resistance small r into area. R2 will be resistance into pi A by 2. See now, when you go from O to P, A, B, C, D, why are they different? You tell me. If you want to go from O to P, how many ways you can go? 4 ways. Every path that you take through A, I can show you same path through B, isn't it? Same thing I can see from C also, same thing I can see from D also. You could have folded it also actually. If you can fold this, A, B, C, D, all will fall on the same point, right? A, B, C will become identical if you fold this. Do check it out. So this guy is like R1, R1, R1. There are 4 R1s and there are 4 R2s. Series parallel, you're done. So R equivalent would be 1/4 of R1 plus R2. Check. This is very important. You know, it's a good model. Right? You know, they can ask a question like this also.
So why are we taking 1/4 of it?
All 4 are in parallel, right? 4 of them are in parallel, na? It will become 1/4. Capacitor nahi hai, be careful. Clear? Clear, everyone? Next one. So there, that is some circuits there, series, parallel, bitstrings and all. Then we have something, this is being asked a lot nowadays. Color coding. This you need to mug up. There's no logic there. So if you ever seen a resistor, If you ever go into a lab and see a resistor, it looks like this. This is how resistors look. They have a color coding on top of it. So seeing that color, you can tell what is the value of the resistance. Okay. So the logic here is, if you take a resistor, each color denotes the number. See, black color digits 0, brown is 1, red is 2, orange is 3, blah, blah, blah. How to remember this? There is some mnemonic actually. BB Roy, great British, is a very good one. I don't know what
BB
that is. So there are different ways you can remember this. So this is one of the mnemonic. So BB matlab, the first thing is like alphabet. Black, blue, red, orange, yellow, green. I think this is again brown, violet, green, gray, white. You have to mug it up. Every year they're asking definitely one question. 6 papers now. Ek do paper mein aa rahe answers. So this you need to mug it up. BB Roy, I don't care if you mug it up. So, but how to do the color coding? Let me show you that. So, example, if you take this thing now, let's say the first one is a red color, then you have a green color, and then let's say you have a yellow. ये तो yellow नहीं दिख रहे हैं actually. Let's say black. Black नहीं. Let's put again red only, big deal. Then again put red. And the last thing is let's say gold. You have a resistor like this. Now the meaning of this, you know what? The first symbol that you see is your first digit. The second color is your second digit. The third color is the power. The fourth color is the tolerance. How do you know you have to see from the left and not from the right? Look at this thing. Gold, silver will not have any numbers. The gold and silver will not have any numbers. So gold and silver will be always on the corner. You have to start from the other side. Don't start from gold or silver. So in this diagram, you can clearly see the gold here. Can you see the gold here? So means you have to start from the left-hand side. So how do you write this thing? So what is the first color here? First color is red. Red is 2. So 2. Second color is green. That is 5. 5 into 10 power. Again red. Red is 2. Plus or minus tolerance is the error in the resistance. 5%. Gold is 5%. Are you getting what we did? So the first color will denote the first digit. Second color is the second digit. Third color will denote the 10 to the power. That's the third color. Can you tell me what is the resistance of this here in this diagram? If there's no gold and silver,
10
then we're
into-
confused.
10
Henry
into
South 3.
10 to the power 2.
2.
10 into 10 to the power.
Normally it should be present, right? If it is not present, we are gone. We can't tell anything.
1000.
Iska kya tha? First color is what? See, gold is on the right hand side. So first color is brown. This was brown. First of all is brown. Then you have black. So first color brown is 1. Black is 0. Into 10 to the power of red is 2. Gold is plus or minus 5%. So this is 1000 ohms. Isn't it? Yeah. All got this? Suppose if I give you like this, 336 into 10 power 5 ohms. इसका कलर्स क्या होगा?
Orange, blue, green.
The first is 3. First would be orange. 6 is blue. 5 is green. Tolerance of the any. Clear? Let me show you how they asked a question in the exam. Question ऐसा था. This is too small, right? What is the answer for this? This is how they asked in JEE. They said 333, find the colors. Or they'll give the colors and they'll ask you find resistance. If you don't remember this color coding, you will die. Simple marks, just need to mug it up.
Fourth option, right?
First thing he said plus or 5 minus gold tolerance, na? मतलब gold होना चाहिए. So this is gone and this is gone. silver is gone. Then orange, sub orange. I think third alphabet you have to see. Third is what? 3, na? Actually, now this question is pretty, nice. You could have guessed it also. Because see, this is 3, 3, 3, meaning all three should have same color. So this is also wrong. And then kilo ohms, na? Kilo means that is also 10 power 3, na? That also should have same color. This is the only option. So even if you don't know color coding, you can still tell the answer. You could have guessed this. I think that was the whole purpose of this question, I guess. Even then, you won't remember. That is that much, so you can figure it out. 333 into 10 power 3. That way. Or let's say, even if you give you 333 into what is red here, 10 square, then you know, no, it can't be all 4 can't be same color because it is 2. Then that would have been wrong. Either way, you could have figured it out. Clear? There. So you need to mug up the color coding. Next one. Kirchhoff's law. It's not that different from, capacitors. The idea is the same. The sum of the potential differences across the elements, it is exactly the same definition. So Kirchhoff's junction law, what it says. So I1, I2, I3, I4. The current entering a node should be equal to the current leaving the node. Straightforward. This is nothing but law of conservation of charge. The next thing, Kirchhoff's loop law. It's same as, this thing. The sum of the potential differences across the elements in a loop is 0. This is the most important one, sign convention. Listen carefully about this. So if you have a battery, this is a negative terminal, is a positive terminal. Battery ka same. If you go in the negative to positive, plus V. If you go opposite to the battery, minus. This is fine. This too you know. If you have a resistor and a current I is flowing here, tell me one thing. Current flows from where to where? Current flows from where to where? Higher to
Higher
lower
to lower
potential.
potential.
So current always goes from higher to lower potential. Meaning if you go from plus to minus, that is if you go in the direction of the current, potential happen what? Decrease. What is the potential across the resistor? I into R, na? So minus I into R. Potential difference across the resistor is I into R. So if you go from plus to minus, it will decrease by I into R. If you go from minus to plus, that is opposite to the current, potential increase by plus I into R. Same thing, if you take capacitor, if this is positive plate and this is a negative plate, if you go from plus to negative plate, potential will drop. How much? Minus Q by C. If you go from minus to plus, it will be plus Q by C. Check this out. So capacitor, resistor, battery. These are the three things. Idea is simple. Whenever you go from higher to lower potential, potential drops. So in case of a resistor, when current will always from plus to minus. So if you go with the current, potential will drop. In a capacitor, positive to negative plate, it drops. Clear? Any doubts on the sign convention? Please ask. Let's see a problem on that. You'll get the convention, sign convention ka thing. Show you. Let's see one question. Let's see, get the hang of it. Let's say we have a battery, we have a resistor, we have a capacitor. This is 5 volts, this is 10 ohms, this is 2 microfarad. The current is flowing this way, I is equal to 2 amperes. This is minus 6 microcoulombs and this is plus 6 microcoulombs. This point is A and this point is B. Find VB minus VA or VA minus VB. So it's a part of a circuit. Pura circuit I didn't draw. You have one battery, one resistor, and one capacitor. Capacitor ka left plate is negative, right plate is positive. Current is flowing 2 amperes from left to right. Find the potential difference between A and B. This is how they can combine both of them. Try, give it a minute. You put it on whatever you think. Let me show you, then you can verify. That's the best way to learn. Whatever you think, you write it down. Let it be wrong. It's okay. But when I verify, you can check it out. You tell me now, which side is positive? Current goes from where to where? Positive to negative. Current always flows from higher to lower potential. So resistor which is positive, which is negative. If you go with the current, potential will drop. So basically, this guy would be positive, this guy would be negative now. Current always flows from higher to lower potential. See, this is how you write Kirchhoff's law. You start from A, VA, you're going through the battery, minus to plus, so plus 5. Then you're going through the resistor from in the direction of the current, minus IR. Then you're going through the capacitor, negative to positive plate, plus Q by C. You came to B. Isn't this how you write? Please check your signs. Now you just need to put the values there. VA plus 5, I is 2, R is 10, Q is 6, and this is 2. So this would be plus 5 minus 20 plus 3 is VB. So VA minus VB would be, how much is this? 12 volts. Check. Please check your signs. Let me give you one more like this. Right? Clear now? All got this? Kavish, Labdi, Hasni, clear? Anamai? Let's see one more like this. Three volt, 5 volt, 2 ohms, 3 ohm, 1 ohm. This is grounded. This is 2 microfarad. This was the positive plate, 4 microcoulomb. This was 2 ampere. This was 1 ampere. Let's say this point is A and this point is B. Find V and VB. Find the potential at A and B. They'll play like this with capacitor and resistor ka Kirchhoff's law. These are pretty good ones. Not tough, but you should know. Chirayu, Dipanshu, Divyanshu, cams on. Shaurya. On the right side is grounded. That is 0. Start from there. If you want, you can just call this point C. Try. Let's see. Start from C because C is 0. Now, first thing before that, you need to figure out something here. You don't know the current in that branch. What is the current in this branch?
3.
3 amperes, junction law, isn't
Yeah.
it? 2 is coming from here, 1 is coming from here. So 3 has to go this way, isn't it? There's a current in that branch. 3 ampere. I just didn't show you, but you have to figure it out. That 2 is coming from here, 1 is coming from here. Kahan pe ja rahi hai sab current? It should go somewhere. So there is a 3 ampere ka current in that branch. Don't forget that. So 3 ampere is flowing this way. I think then from here you'll get it. Start from C. VC. Then you're going opposite to the current. So plus 2I into R. Then you're going from negative to positive plate plus 4 microcoulomb by 2 microfarad. Then you're going down. I'm going from VC to VA. Again, you're going opposite to the current. So 1 into 1. Then you're going with the battery plus 5 and you reach VA. Please check this. I'm going completely opposite to the current. So it's always adding up. So VC is 0. This is 6. This is 2 plus 1 plus 5 is VA. So VA is 14 volts. Now same thing. I can go from VC to VB. VC plus 3 into 2 plus you're going from negative to positive plate 4 microcoulomb by 2 microfarad. Please ask me if I get confused. You're going opposite to 3 volt battery. You're going opposite to the current. So plus 2 into 3, you reached VB. VC is 0. This is 6 plus 2 minus 3 plus 6. That guy would be 6, 6, 12, 12 plus 2, 14. 14 minus 3 VB is 11 volts. Please check this out. Ask me if you're confused with the sign convention. Right, Kavish, you got it right. Others, anyone? If you go opposite to the current, think like this. Simply think like this thing. Huh? Let's say there is a river flowing from a mountain. How does the river flow? River will flow from higher height to lower height. Make sense? River will always flow from higher height to lower height. If you go with the river, will your height increase or decrease? Height decreases. Isn't that like potential here? Height is like potential here. If you go opposite to the river, are you not climbing the hill? If you go opposite to the river, your height will increase. If you go with the river, your height will decrease. Is that making sense? So if you go with the current flow, potential should decrease. If you go opposite to the current flow, potential should increase. So current flowing in a wire and water flowing from a hill is exactly same. Here we call it potential. There we call it gravitational potential. There we call it water flow. Here we call it electron flow or current flow. Clear? That way, the current always flows from higher to lower potential. Okay, so with this we'll wrap up for the day. So tomorrow we are meeting again, Sunday, 9 to 10:30. We'll continue from here. We will do more of a circuits in Kirchhoff's law. We will even take RC circuits, like, how to exactly solve them. Here, so I still gave you some constant currents and all. That is a pretty important thing. So do start solving capacitors. At least try to wind up, capacitors, everything by next Thursday. Put a very strict deadline and do as much as you can, right? Don't extend it. It will keep on going forever. And the next test is already online advanced thing. It's like 1/3 of the paper is capacitors and remaining is Gauss-Lorentz capacitors. So do give it a try. Okay, so I'll see you guys tomorrow at 9 o'clock. So any doubts, anything, please stay back or else free to leave. So take care, stay safe. I'll see you tomorrow.
Thank you, sir.
Bye, Ray.
Sir, in the star wala question that we did,
Uh-huh.
uh, I folded it.
कर सकते हो fold.
But usse I'm not getting the answer. I sent you my.
Fold किया तो कुछ नहीं होगा. देखो, if you fold it ना, this will fall on this, this will fall on this, this will fall on this ना.
So everything becomes 2 times.
ना half होगा. Resistors in parallel.
Oh,
Capacitor नहीं है.
okay, maybe that's why answer नहीं आ रहा.
Capacitor में double होता है, resistor में half होता है.
Okay, ठीक है. And
Got
then
it? Yeah. You have to be careful. थोड़ा वो, you have to be careful. चलो.